resonances in musical instruments and how they help us figure out how instruments are constructed and made and all the things that are associated with it. So most musical instruments are played by either striking, hitting, plucking, or somehow disturbing the instrument. These different methods all result in causing the system to undergo vibrational motion or simple harmonic motion. Each natural frequency of the object is associated with one of many possible standing wave patterns at which the object could vibrate. The natural frequencies are called harmonics, and in order to understand them, we have to start understanding standing waves. And we talked about standing waves, right? Standing waves are those waves that don't go anywhere. So these are the waves that look like that. We also talked about standing waves in 1D, which would be standing waves caused in a string. We talked about standing waves in 2D, which would be standing waves in a membrane, like, drums and stuff. And then we talked about standing waves in 3D, which would be standing waves in instruments like the trumpet or the clarinet or any wind brass instruments, for example. So standing wave concepts are very important when we talk about musical instruments, which is what this talks about. So musical instruments, for example, when you're talking about a brass instrument, it's a column of air that's inside the instrument that is actually being set into motion. And the column of air is always a 3D motion. So it's basically the air molecules that are vibrating, right? And how do we make it vibrate? So anyone a trumpet player? Yeah, how do you make it vibrate?
It's called buzzing your lips. So that causes vibration like on your actual face, and then that gives.
So when you start, when you first started, does it start buzzing immediately or does it take a little time?
If your air is at the right speed, it should start immediately.
Okay, but how often does that happen?
Not often, depending on.
Okay, so, and there is a very physicsy reason for that to happen. Because what you're doing by buzzing your lips is actually setting up standing waves. And those waves have to be reflected back in your instrument before it becomes loud enough for it to be ejected outside. That time delay is caused by the fact that you are creating standing waves in your instrument, and they have to be amplified. So both concepts that we learned, right? Resonance and standing waves have to happen before any sound comes out. And yes, you're right. So people who are really good at doing it really, really fast, and it takes a lot of practice for you to be able to do that, right? When you first start playing that instrument, it's going to take time before that happens. And that's exactly where resonance comes in. So resonance is that particular phenomenon of causing the instrument to play at its natural frequency, which amplifies the sound. Otherwise, this would happen. And what did we call this phenomenon? Starts with a D. Damping, right? So it goes smaller and it'll disappear. So how did we say we do this resonance phenomenon? Think of the swing. When children swing on it, do you just push them once and then let them go? Or do you have to do a little push every time? And we called it a certain thing in physics. Forced oscillation, right? Where the buzzing in the trumpet, that's the best example I could give you, right? You have to keep buzzing it. As soon as you stop, what happens? The sound dampens and goes away, right? Make sense? So all of these phenomena are basic physics behind it. Do we understand? Damping, resonance, and standing waves. Thumbs up, bobbleheads. Excellent.